So pH, you've probably heard of this before. It gets talked about in earlier science classes, and you saw a little bit about it in some of the intro activities we did. If you know anything about pH, you should know that our acid pHs are going to be 0 to around 7, and our base pHs are going to be greater than 7 up to 14. You notice I didn't actually technically include 7. That's because exactly 7 is neutral, and how close you can be to 7 and not quite be counted as neutral is kind of a matter of debate. Anything really close to 7 we generally consider neutral. The reason that acids have this low pH is because they've got a lot more H than they've got OH, or at least a little bit more. We know H comes from our acid and OH comes from base. And even in a really acidic solution, you've got a little bit of OH because of how water works. Our bases, you have a high pH because our hydrogen concentration is low and our hydroxide concentration is high. These square brackets just mean that's our concentration. And you should remember from 9-3 that concentration in chemistry we generally deal with in terms of molarity. And in chemistry, what do we mean by pH and other things? P just means take the negative log of it. The P comes from the French word for power, which I'm not going to attempt to pronounce because I didn't take French and it's going to be silly. But anytime you see P of something, it means take the negative log of it. So for pH, that means we're going to find our pH by taking the negative log of our hydrogen ion concentration. For hydroxide, we can take our pOH, which again is just our negative log, but this time of our OH concentration. And because of how math and water works, pH plus pOH equals 14. The reason for this, a bit beyond the scope of this course, you'll sort of cover why in Algebra 2. But you just need to be aware, pH means take the negative log of H. pOH means take the negative log of OH. Then pH plus pOH can be 14. So that way, if you need to find, say, the pH of a base, you can use this. So our very first question we want to try is, what is the pH of a solution if the H concentration is 1 times 10 to the negative 6th? And so again, we just said pH means take the negative log of my H concentration. This is my H concentration. So we're going to plug that in the calculator. Do you know what log means? Probably not. But you don't really need to worry about it, other than we're going to hit the button on the calculator. It has to do with finding exponents. We mostly worry about the button. So all we need to do is take the negative log of 1, and remember, use your E key if it's in scientific notation. E, which replaces times 10 to the negative 6th. Close parentheses. That gets our answer is 6. Not so bad. Now we want the pOH of the solution. So remember, pH plus pOH equals 14. So if I'm trying to find the pOH, that's going to equal 14 minus my pH, which is going to be 14 minus 6, which I should be able to do in my head, but that just gives us 8. Pretty straightforward. All right, now why don't you pause and try the problems at the bottom, and then come back and join me. All right, so here's a little more practice. We want to find the pOH of a solution with a pH of 3.2. We just talked about that one, that pH plus pOH equals 14. So if I need to find my pOH and I know my pH, it's going to be 14 minus my pH. Same would work if I knew my pOH and needed my pH. It's just 14 minus the other one. So here we're going to have 14 minus my pH, which is going to be 14 minus my 3.2, which gets me 10.8. This one wants the pOH of my solution if I've got an OH concentration, a hydroxide concentration of 4.6 times 10 to the negative 9. Then it wants my pH. So remember, the first order of business, pOH means take the negative log of it, so negative log of my OH concentration. So we're just going to plug that in the calculator. So we've got the negative log of 4.6 times 10 to the negative 9 gives me a pOH of 8.34. Now to find my pH, we know that pH is equal to 14 minus pOH. So that's going to be 14 minus 8.34, which will give us 14 minus, this is where history is your friend. I can just bring that number down without retyping it. So we get a pH of 5.66. There we go. Now, this last one, we're going to do all of our steps that we possibly can. Given that our H concentration is 5.5 times 10 to the minus 4 molar, we want to find all of these things and then decide whether it's acidic or basic. So pH, I'm given my H, so pH is going to be my negative log of that H concentration. I'm just plugging it into my equation. And so I just plug it in my calculator from there. Negative log of 5.5 times 10 to the minus 4 gives me a pH of 3.26. All right, so now I've got to go to my pOH, and pOH, remember, is 14 minus pH. So that's 14 minus my 3.26 I just found, which is going to equal 14 minus the answer I just got. So 10.74 is my pOH. Now I need to decide, is this an acid or is this a base? Just because we have an H concentration doesn't automatically make it an acid, because even bases will have some H. But if we look, I've got a pH of 3.26, and we know that any pH that is less than 7 is going to be an acid. You can technically also find it from pOH, but that tends to mess with people. All right, so that's all the math that you need to be able to do on this practice assignment. Go try that on your own. If you're still having questions, ask your teacher.